Hello there, and here are your notes. So let's underline that, notes. And it's section 2.3b. And we're going to be combining the two things we've just learned recently. We learned the distributive property, and we learned how to add like terms. And we're going to put that all together into one big problem. So here we go. Let's look at problem number 1. Hopefully you notice distributive property right here. So we're going to take -2, and we're going to multiply it by x, and then we're going to take it and multiply by 4. So that will give us, let's see here, -2 times x is -2x, and -2 times 4 is -8. Now when we keep looking down the problem here, we should make a double sign change. 1, 2. So then that gives us plus 4x. And the last thing in the problem is the plus 6. Alright, let's rearrange it, putting all the like terms together. So let's write -2x plus 4x. And we can rearrange in an addition problem. That's just the commutative property. And then plus -8. And then plus 6. And we will add the like terms. Kind of like putting all the hamburgers together. So right here, -2x plus 4x is 2x, plus -8 plus 6, that's like the French fries, is -2. And that's it. That would be your final answer. Alright, let's look at number 2. Hopefully you notice right here that you need to distribute the 3. So we're going to go 3 times x, and then 3 times 3. And let's write our answer, I guess right here. So again, -3 times x, then, positive 3 times x, then 3 times 3. So 3 times x is 3x. 3 times 3 is 9. Now at the end of the problem there is a parenthesis. There's no number here to distribute. I guess you could think of a positive 1 there. But there's really no multiplication involved here. So let's just rewrite -3x plus 2. Rearranging this using the commutative property of addition, we'll go 3x plus -3x plus 9 plus 2. And we'll add the like terms. A 3x plus a -3x, that's nothing, it's gone. 9 plus 2 is 11. And so our final answer this time is 11. Alright, number 3. There's distributing here. Also, I need to make some double sign changes. I need a double sign change here and here. So let's start with the double sign changes. 1, 2, 1, 2, 1, 2. And then let's draw in our distributing arrows. Alright, I'm going to take that 4, that outside 4, multiply it by -x squared, then I'm going to multiply it by x, and then I'm going to multiply by -3. So 4 times -x squared is -4x squared. Then we'll take the 4 times x, which is 4x. Then we'll take 4 times -3, which is -12, so we'll put plus -12. Now I also need to distribute this -2 right in here. That's a distributive property of multiplication with respect to addition. So that's going to give me -2 times x, -2x. -2 times -3 is 6. And then don't forget about the plus 15. Alright, we will rearrange this. We'll have -4x squared plus 4x plus -2x plus -12 plus 6 plus 15, and now we'll just add like terms. The -4x squared is just all alone. We'll leave it all alone. Plus, these two are like terms. They both have an x. 4x plus -2x is 2x. And then -12 plus 6 plus 15. Let's see here. I think that would give me 9. And that would be it right there. Final answer. All right, the last problem. I should maybe slide a 1 here in front of that lone x. I need to make a double sign change. And here is where the distributive property of multiplication with respect to addition comes in. So there goes my 1. There goes my double sign change. And here's distributing. Alright, I'm going to move my paper up a little bit. And here we go. I will get 1x plus the 10 plus the negative 7x plus, now I'm distributing, 3 times 2x is 6x and 3 times 4 is 12. Let's rearrange. We'll have a 1x plus the 6x. Whoops, I missed something there, didn't I? 1x plus negative 7x. 1x plus negative 7x plus 6x plus 10 plus 12, and add my like terms. If I add these first terms, they all have an x. 1x plus negative 7x plus 6x. I believe that's 0x, so nothing. And then we have a 10 plus a 12. 10 plus 12 is 22. And so my final answer this time is 22. Alright, so what are the steps that I just took on all these problems? So let's kind of summarize it here. Steps. First step, double sign change. That is so helpful. Second thing, sometimes you need to put a 1 in front of a lone letter. So a 1 next to any lone letters. Third step, I distributed. Distribute, and then the fourth step is add like terms. Alright, so that's kind of the steps that you should think about following. Also maybe looking at these examples. Alright, let's move on down here. Talk about area. Area is counting the squares that cover a surface. Counting the squares that cover a surface. Counting the squares that cover a surface. And we're going to deal with rectangles, area of a rectangle, so switch that to rectangle. And we're also going to deal with triangles. So I'm sure you've learned this formula. So first let's do the area of a rectangle. Start with that formula. And hopefully you know this formula already. And it's just base times height. Base times height. So if you're going to cut this up into squares, the quickest and easiest way to count them is just to count the base and times it by the height. Okay? And that works with algebra also. The formulas aren't going to change. And then there's also a triangle. And triangles have different formulas. So the area of a triangle has a different formula that you need to know. And for a triangle, you know what, you just take a rectangle. So let's just look at this rectangle right here. You just take a rectangle and you cut it in half. And that gives you a triangle, right? And so that's what the formula basically is. You just take the rectangle formula and cut it in half. So it's going to be 1/2 times base times height. Alright, so let's do these two examples. I always start with a formula. So for number 1, it's a triangle, so I'm going to use the triangle formula. 1/2 times base times height. And now you just plug values in. So 1/2 multiplied by the base, in this case the base is 14, and then we're going to multiply that by the height. And it's easy to find the height because it's always perpendicular to the base. There's always a little h drawn. See the h? So that's the height, how tall it is. And in this case it's 5x plus 10, and you need to group that in parentheses because the 5x plus 10 describes the height that goes together. Alright, I'm going to move this up a little bit. And here we go. Half times 14, times means of. Half of 14, half of 14 is 7. And then you still have the 5x plus 10. And then you distribute. You take that 7 and you distribute. And 7 times 5x is 35x. And 7 times 10 is 70. And since we're counting squares, in this case, it'd be square inches. Alright, number 2. This time the shape is a rectangle, so I use the rectangle formula. I like to start with the formula first, so base times height. In this case, the base is 4x plus 4, and you put that together. That is one thing. It is the base. It all goes together. And here's your height. And now you just take that and distribute. And you will get 8 times 4x is 32x. And 8 times 4 is 32. And again, we're counting squares, but this time there's square centimeters. So you write square centimeters. Alright, I hope this is helpful. Watch the second video for the back side.